You are on call. It is 20 past 2 in the morning and the checkout service is returning 503 to about 1 in every 9 requests. You open the dashboard. Every one of the 4 checkout machines is healthy. CPU is fine. Memory is fine. The load balancer says all 4 are passing their health checks. And yet 1 in 9 customers cannot pay. So what is dropping those requests? Hold that question. We will come back to it at the end, because the answer is the whole reason these 2 boxes are not the same box. Here is what we will work through. First, why the usual definition is wrong. Then we will build a system from one machine until the gap opens up on its own. Then we will solve your incident. Then we will divide the responsibilities properly, name the real tools, and finish with the 5 questions you should ask before you adopt anything. Here is the sentence you have probably read, or said, or nodded along to in a design review. The gateway is basically a load balancer with extra features. Simple. And it sounds reasonable. Both sit in front of your services. Both take traffic from outside and hand it to something inside. Both can terminate encryption. Both can be configured to spread requests across machines. But we should really avoid defining a thing by the thing it superficially resembles. Let us try again. Take 2. Maybe the difference is where they live. The load balancer is layer 4, the gateway is layer 7. That has the pleasant ring of precision to it. Does that hold up? No. It does not. The load balancer sitting in front of your web tier right now is very probably a layer 7 load balancer. It reads the path. It reads the host header. It routes on both. So if layer 7 made something a gateway, would your load balancer already be one? Yes, and the distinction collapses again. Let us try this one more time. Take 3. Start from what each one is trying to be right about. The load balancer is trying to be right about machines. It holds a list of interchangeable backends and it answers one question, over and over, thousands of times a second: which of these healthy machines should take the next request? Its whole worldview is that the backends are identical. Is that a limitation? No, it is the point. Interchangeability is what lets you add a 5th machine at 9 in the morning and remove it at 6 in the evening without telling anyone. The gateway is trying to be right about callers. It holds a model of who is asking, what they are allowed to ask for, how often they may ask, and what shape the answer should take. It does not assume the things behind it are interchangeable. It assumes the opposite. Behind the gateway are the payments service and the catalog service and the search service, and they are nothing like each other. So the honest formulation is this. The load balancer distributes load across things that are the same. The gateway mediates access to things that are different. Note, both of those jobs can be performed by the same piece of software. Jinx can do either. Envoy can do either. That is exactly why the confusion survives. The distinction is not about the binary you installed. It is about which question the box is authoritative for. Now, back to your incident. Let us build the thing that is failing, from nothing, the way it actually gets built. Say your team ships a product called Wayfare. It is one service. One machine. Users hit it directly by address, which is fine, because there is nothing to choose between. Then the machine falls over on a Tuesday and you lose 90 minutes of sales. So you run 3 of them. Now something has to choose. You put a load balancer in front of Wayfare, and it starts answering that one question, thousands of times a second: which of these 3? Note, this is the moment most teams stop thinking about the front door, because at this point the front door genuinely is solved. 3 identical machines, 1 chooser, health checks removing the sick ones. That is the correct architecture for the problem you have. Then Wayfare grows. Checkout becomes its own service because payments logic should not redeploy every time somebody changes the catalog page. Search becomes its own service because it needs different hardware. Now you have 3 services, each running on 3 machines. What is your load balancer supposed to do now? You can make it work. You add a rule, /checkout goes to the checkout pool, /search goes to the search pool. It routes on path. And this holds up for a while, which is precisely what makes it dangerous, because the thing that breaks next does not look like a routing problem. A partner integration asks for programmatic access. So now you need keys. Where do the keys get checked? You could put that in every service. 3 services, 3 implementations of key checking, and by next quarter they have drifted, and one of them is comparing keys with a plain equality check that leaks timing information. You have made the same access decision 3 times and got 3 different answers. Then a customer's misconfigured retry loop sends 40,000 requests in 90 seconds and takes down search for everybody. Where does rate limiting go? Same question. Same 3 wrong answers. Then mobile ships and needs 1 call where the web client makes 4. Where does that get assembled? Analogy: think of the difference between a doorman and a receptionist. The doorman decides which of the 4 identical lifts you take, and does it well and fast without knowing your name. The receptionist knows who you are, whether they have booked a slot, which floor you are permitted on, and how many times you have already been in this week. Would you ask the doorman to check appointments? He is optimized for lifts. Every one of those problems, keys and quotas in shaping, is a statement about the caller. And you have no single place that knows about callers. That absence is the gateway-shaped hole, and it opens up whether or not you have noticed it. So let us go back to your 503 at 20 past 2. Here is what was happening. All 4 checkout machines really were healthy. The load balancer really was doing its job correctly. But one client, a partner batch job, had begun retrying aggressively against /checkout, and it was consuming most of the connection pool. Your other customers were queuing behind one caller's traffic and timing out. Now look at the shape of that failure. Is it a machine problem? Nothing was down. It is a caller problem. One caller was taking more than its share. Ask your load balancer to fix that, and you are asking a question it structurally cannot answer, because a load balancer does not have callers in its model of the world. It has back ends. It can tell you that all 4 are healthy, and it was telling you exactly that, all night, truthfully, while your customers failed to pay. Case in point, Amazon suffered a well-known outage in 2017 where retry storms amplified one initial fault far beyond its original blast radius. The pattern is general. Retries are polite in isolation and vicious in aggregate. Something has to hold the line on how much any one caller may consume, and the only component positioned to know that is the one that models callers. So what actually goes where? Put on the load balancer the things that are true of machines. Health checking and ejecting the sick. Spreading connections. Draining a machine before you patch it. Keeping traffic in the nearest zone. These are all statements about back-end fleets, and your load balancer is the right authority for every one of them. Put on the gateway the things that are true of callers. Who is this? What may they reach? How much may they consume? What does the response look like for them? Where do their requests get recorded so you can answer, later, why a specific customer saw a specific error? Quick win: if you have nothing today, do not start by adopting a large gateway platform. Start by moving one decision, caller identity, out of your services and into one place. It is the decision that hurts most when it drifts, and it is the easiest one to verify you have got right. You will meet several real tools here, and it is worth knowing which question each was designed to answer. HAProxy and Jinx grew up answering the machine question and are superb at it. Kong and Apogee grew up answering the caller question. Envoy is genuinely both, which is why it ends up underneath service meshes, where every service needs both roles at once. On AWS, the application load balancer is a load balancer that has learned some path routing, while API Gateway is a caller-oriented product with quotas and keys and usage plans. Kubernetes has its ingress object, which is mostly the machine question, and now a gateway interface, which reaches toward the caller question. Notice how many of those can be configured to do the other job badly. That is the trap. The question is not, can this tool do it? The question is, which failure will this tool be able to explain when you are staring at a dashboard at 20 past 2 in the morning? Now the honest part, because this is where advice usually goes wrong. Caveat: you may not need a gateway at all, and it may not be worth the effort. If you are running one service, or 3 services all called by one first-party web client that you also own, then a gateway is a component you will have to run, patch, monitor, and debug, in exchange for solving problems you do not have yet. A path rule on your load balancer is not technical debt when you have one caller. It is the right size. Be cautious here, because the cost is real and it arrives immediately while the benefit arrives later, if at all. There is a second honest caveat, and it is larger. A gateway is riskier than it looks, because it sits on the request path of everything. If it is down, you are down, all of you, at once. Teams reach for it expecting simplification and discover they have introduced a component that needs its own capacity planning, its own deployment story, and its own on-call rotation. Many teams underestimate that work. It also becomes a tempting place to put business logic, and business logic in the front door is remarkably hard to get back out. So this still requires judgment that no diagram will make for you. So ask yourself these 5, in this order. How many distinct callers do you have, and do you control all of them? One first-party client is a different world from 40 partners. Do you make the same policy decision in more than one service today? If caller identity or rate limiting is implemented twice, you already have the hole, whether or not you fill it with a gateway. Can you answer, right now, which caller consumed the most capacity in the last hour? If not, you have no caller model, and no amount of back-end health data will give you one. If your front door failed, what would you lose? Because a gateway concentrates risk as well as policy. Is the problem you are solving actually about callers? If it is about machines, you already own the right tool, and it is working. Get those 5 answers and the choice usually makes itself. Sometimes the answer is a gateway. Often the answer is that you needed one policy moved to one place, and you can do that without adopting a platform. Ask yourself these questions and you can answer them confidently, which is more than most design reviews manage. We left one question open near the start of this, about what was really dropping those requests, and now you have it. The load balancer was not wrong. It was answering a question about machines with complete accuracy while your actual failure was a question about callers, and it had no way to see it or to say so. Which leaves the real question, and it is about your system rather than this story. When your front door next tells you everything is healthy, will you be able to tell whether it is right, or only whether it is answering the wrong question well? That one is your call, and you should decide it before the next incident decides it for you.